There's a new remote control station controller from George at Packtenna. You guys are going to know him from the ham radio workbench and or the Packtenna antennas that he makes. He came up with this complete, almost plug and play, run on a Raspberry Pi system to control your repeater remotely, but your HF radios and your ham radios in your Hamshack remotely. And it's brand agnostic. It's not tied to one brand like ICOM, Yaesu, Kenwood, Flex, or anything like that. It'll work for just about anything. It adds a bunch of different stuff to it. It's all plug and play. It runs Node-RED for monitoring. We're going to talk about it today. This is a cool project, and I hope you guys enjoy it. Tell us just start at the beginning, I guess. Tell us what this is, what we're looking at here. Because when I got this is the box of stuff that I've got here. And this is I didn't do this on purpose. This is just how messy I always keep my bench. So
you're a ham.
So yeah, exactly. Yeah. So yeah, tell us, George, thank you for being here today, first off, and tell us what we're looking at here. I see you're operating under the name Sierra Radio Systems. And is that new, or have I just not heard that before?
No, nobody's ever heard of it before because Sierra Radio Systems, I started that 20 years ago, actually 19 and a half years ago. And the purpose for that company is to make repeater control systems and accessories. Mm-hmm. And so we've been making repeater controllers ever since then, mostly used by very large multi-site linked networks. So this is not like a little tiny controller. These repeater controllers are 3U racks with a bunch of boards. It's pretty fancy. And the market for that is very, very specialized. So it's only people who are building big network linked repeater systems would buy such a thing. And so so that's where that started.
Okay, good. Okay. Well, that's a little background of that, because I think most people would know that you're either George from Packtenna or from Ham Radio Workbench. So that was just another name that I saw in Michael's video, but also on these labels here. So I'm like, okay, I just wanted to clarify that. All right, good. So tell us what we're looking at here.
Okay, so in a way, if I go back to, we just talked about repeater control systems. So I've been building control systems for over 20 years. And one of the other interests of mine besides portable operating and building repeaters is remote operating. And so I've thought for many years that I should build some kind of remote station control thing and leverage the experience I had with repeater controllers. So I started working on some projects a couple of years ago to build some remotely controlled coax switches for my shack, just for my own personal use, and made a couple of early versions of that we made available through the Ham Radio Workbench podcast. We made a 4-port coax switch at the time. And so this last year, I decided that I was thinking about this for long enough, I should actually make something. So I started seriously working on what I'm calling the station controller. And so I think it would be useful to define, well, what is a station controller? Because if you walked up to any ham and say, hey, what's a station controller? They wouldn't know what you're talking about.
And it could, realistically, it could mean several things, right?
Exactly.
Yeah. It's kind of a generic term, but yeah, okay, good deal. All right, good. Go ahead.
Okay, so the way I think about it, station controller, each of those two words really kind of mean something. So what's a station? So the first definition of station is my Hamshack. So that's my station. And but there's other kinds of stations too. If you have a repeater up on a mountaintop, that's a station as well. Or maybe you really think about a remote operating where I'm, traveling and I'm going to use my laptop to connect back to my station at home. So I'm remote controlling my station. So that's the station could be anything that you want to remotely monitor or control. So the controller part of station controller really means monitoring key vital signs in the system and being able to control a lot of them. So if you think about, let's say you're doing a remote HF ham station, you've got a Flex radio or an Elecraft or an ICOM or whatever, and you want to remote that radio, there's several things you have to have in place to successfully remote a radio. So obviously you have to be able to control the radio, and you have to be able to send audio back and forth from your client, laptop, tablet, whatever, to that station. Now, that part of the problem is being solved largely by the radio manufacturers. So if you look at radios, let's say 10 years ago and before then, most radios have serial ports, so they're controllable through a serial port, but you have to have some third-party piece of hardware or software to deal with it. But the modern radios, at least the I'd say the mid to high end radios today, are architected with remote control in mind. So Flex from the beginning
Mm-hmm.
was really a remotable radio, and they're probably the best example of that today.
Mm-hmm.
Elecraft K4 series is also built in a way that makes it naturally remotable. The ICOM 9700 and the 7610 and other ICOM radios make it easier to remote because they have network connections and they can pipe
Mm-hmm.
audio. So that part of the problem is kind of being solved, and I really didn't want to address that. So there's other
Mm-hmm.
people already
Mm-hmm.
doing it, so that's great. But when you think about building a remote station, that's not everything you need. In addition to the radio functionality, you also need to be able to control and monitor the environment around the radio itself. So what does that mean? At a bare minimum, you need to be able to remotely turn the power on and off to the
Mm-hmm.
station.
Mm-hmm.
And by the way, that's it's a convenience, it's a safety issue, but it's also a legal requirement. So if you are operating a remote transmitter, you have to have some kind of control on the
Mm-hmm.
transmitter. And the best example goes back to, building a repeater. Part of the regulations are you have to have some way to control that repeater transmitter to be able to turn it off if something goes haywire. Same
Mm-hmm.
thing is true for your remote Hamshack. So you need to remotely turn power on and off. But then there's a lot of other stuff you might want to do. You might want to, for example, switch between antennas. Maybe you have a dipole and a vertical or a beam and a dummy load, and you want to switch your radio between different antennas. Perhaps you want to monitor some key measurements like what's the battery voltage if I'm running on a
Mm-hmm.
battery system? What's the solar
Mm-hmm.
panel voltage? Do I have AC power in the shack or did I lose power? Which is not uncommon for a lot of remote stations.
Mm-hmm.
A very critical thing you want to monitor is the transmission line. So what's the forward power from my transmitter to the antenna, and what's the reflected power coming back from the antenna? So
Mm-hmm.
if you have a high SWR, you want to know about that and take some appropriate action. So you might want to measure the temperature on your amplifier or inside the shack or outside the building, So the list goes on and on. So it really
Mm-hmm.
boils down to you need to be able to monitor voltages and switch closures and flip relays, measure RF wattage, et cetera. So all of that kind of stuff is what the station controller addresses.
Okay. Good. Yeah, add an amp into the mix, and you've got even more stuff you need to power
Oh,
off and on, and
yeah.
adjust RF output on the radio, perhaps, depending on what the amp is and that kind of thing. So yeah, okay, that all makes sense. Good.
So by the
Okay.
way, just give you an example, I was talking to Mike VA3MW yesterday, and Mike's
Mm-hmm.
been doing remote station operation for many years,
Mm-hmm.
and his remote station is like I don't know 100 miles from home, so it's not
Mm-hmm.
like you can just walk over there and flip a switch.
Right.
And he has one of my station controllers, and he's planning to replace the stuff that he's been using for a while with the system permanently, and he said, guess how many relays I need? I said, I got no idea, man. How many do you need? He said, I need 24 relays.
Oh my gosh.
So now that, Mike is kind of, I would say at one end of that, complexity spectrum because he has lots of antennas and a
Mm-hmm.
lot of stuff he wants to switch. So that's kind of at the high end of the range,
Right.
but things could get pretty sophisticated.
Is it expandable to that many?
Oh yeah.
Okay. Okay. Well, that's good to know. Cool. Okay. So what? So we've got. Let's. I guess the next step is just let's talk about the image that you have. So this all runs from a Raspberry Pi, and you're currently the image you currently use, or maybe the software for the image, is running on best run on Raspberry Pi 3. And I know you said you were going to work on a Pi 5 later. I don't know what the status on that is, but
Yeah, the Pi 5 is running now. Actually, there's even a little
okay,
bit more to it than that. So so
okay,
the con so if I take a step back before you hop into the Raspberry Pi part,
sure,
the architecture of the system is very modular. So you can think about that there's a control
mm-hmm.
computer and then
Mm-hmm.
there are devices. And
Okay,
the control computer can be almost anything.
mm-hmm.
And when I'm making a packaged product, I need something that the customer can just take out of a box, literally plug it in and have it work. And I think the best recipe for that's a Raspberry Pi. And I made a module that the Pi sits on. We'll talk about what it does probably a little bit. But
Mm-hmm.
you could use the Node-RED flow that
Mm-hmm.
I wrote off the shelf to control everything. And to do that, the minimum thing is you just need a computer that can run Node-RED. So you can take any old beater computer you have sitting in the shack, put
Okay.
Node-RED on it, plug in a $10 interface, and you can control the modules from that. Or you can get my prepackaged, purpose-built board that has some advantages
Okay.
if you want to go with the turnkey solution. So my recommendation off the shelf is to use the Node, this running Node-RED on a Raspberry Pi 3. I tested it on a Raspberry Pi 5. It runs fine, of course. I don't have a 4. Somebody else ran it on a 4, and it's fine.
Okay.
But you can put Node-RED on any Windows, Mac, PC, Linux computer you want,
Okay.
and you could run this application. The other thing is being modular, that interface between the control computer and the modules is very easy to even write your own or create your own control surface. So there's kind of two, in my mind, there's kind of two kinds of hams. There's hams that just like want to go buy a thing and use it, and there's hams that want to design and build something from scratch.
Yes.
And this is applicable to both. So my primary target market, if you will, for this is the first case where someone just wants something out of a box. Um, but if you said, well, I know how to program, I know how to write Python. I want to write my own program on a Mac and control your hardware, then I provide all the specs to do that, and you could easily do that yourself.
Okay. Okay.
Although that's not, I think that's 1 out of 100. But
Yeah. It's like, that every time I put up a video about a out of the box antenna, people are always commenting how you can build that yourself. And I'm like, yeah, you can, but some people just want to get on the air and have fun. So
I tell you, Jason, I'd
yeah.
say 90%, in my experience, like more than 90% of the people that buy something just want it to work.
Right. Yes.
They're interested in how it works because hams are, technically inquisitive, right? So they want to know, like, how does it do that? And they also want to know that if they ever want to extend it themselves, they can. But most people are like, yeah, that's fine. I'd rather it just work because I'm too busy with life to,
Right.
reinvent that wheel.
Yeah, true. Okay, good. All right, well, we have this image here running on a Pi 3, and I have that piped over here to one of my HDMI capture ports, so that's what it looks like right there. And I've got this mouse here wasn't working quite well, but I've got it. If I keep it on this pad on my desk, it's fine. So, but this is a stock. Like, I just imaged this last night, and every time you would announce a new revision, I'd be like, okay. So I download a new revision. I had revision 5 installed, or flashed, I should say, and then you told me about 8 last night. So that's what this is right now. This should be revision 8, and I guess we need to do we need to connect it to the internet now?
You just need to connect it to your LAN so it gets a LAN address.
Okay. That's so small I can't even see it.
We could even do it without looking at the Raspberry Pi. So when you install it, the simplest way to do it is you don't even have to look at the Raspberry Pi.
Okay.
We just plug all the hardware together, because what'll happen is when it boots up, the Raspberry Pi will send the IP address to the display on the controller, and then so you don't even have to log into the Pi ever if you don't want to.
But you'll have to yeah. So I would have to have an Ethernet port for that. I was going to see if I could.
Yeah, so what you want to do is have a Ethernet from your LAN into the Raspberry Pi, and then we'll hook up all the control hardware, and when it all powers up, then the Pi will send the IP address to the display on the control module.
I just got to find an Ethernet cable that's long enough to reach over here. That's the only thing. How close does the Pi need to be to the rest of these peripherals?
You need to have a cable that goes from the Pi. So the Raspberry Pi sits on a host adapter, a custom board.
Okay.
So the Ethernet goes into the Pi, and then you'll notice there's 3 other. No, not that one. There's
not that one. Okay.
One of the larger white modules.
It says host adapter on it, right
there. You go. That one.
Okay.
Open that up.
Good. Okay. Let me switch to the overhead here. Yeah, I got the box in the mail, and I opened it up. I'm like, oh my gosh. Like, how long is this going to take to put together? So
yeah. But, the good news is that the thing that'll take you the most time is figuring out how to screw it to the wall or a chassis or something. The actual system connection is really very straightforward.
Okay, good. All right, good.
So that's the host adapter. So let me explain a couple things. So you'll take your Raspberry Pi, you want to power it down and plug it into this board here.
Right here?
Yeah, right. So the Raspberry Pi flips upside down, and the GPIO header plugs right into there.
All right, so let me do a graceful shutdown because I'm always the guy that's just pulling the power out of a Raspberry Pi, and people are like, I want to say something about that. So, all right, that's fine. Let's see.
So by
Okay.
the way, we talked about the Pi 3 versus 5, and so
Yes.
just a couple thoughts there. I think the best platform to run this thing on is the Pi 3, and the reason is the
Mhm.
Pi 3 takes less energy than the 5, puts out less heat than the 5, and it's more than fast enough to run this application.
Okay.
And they're also very inexpensive. So you can buy a Raspberry Pi 3 for 35 bucks
Yeah.
from
Yeah.
Adafruit.
Yeah.
So, they're
Yeah.
about as cheap as they come. Okay. You can unplug that USB thingy.
Yeah.
Okay,
Okay.
and now flip it over and plug it in with the header. There you go.
Uh-huh.
Now, when you plug it in, you'll notice on this one, this is the beta hardware,
Okay.
and it plugs in fine, but the USB connector touches the base plate. The production ones, that's cut out, so it doesn't hit the little base plate there.
Right. Right
Yeah,
here.
yeah,
Yeah.
yeah.
Okay.
There's a
Yeah.
little notch
Yeah.
there.
Yeah.
Okay, so let me explain
Okay.
what's on that board
Okay.
before we hook it up.
Good.
So on the lower left-hand corner, you'll see a very familiar power
Yep.
pole connector.
Yep.
So there's two power jacks there. There's a power pole and a 2.1 millimeter barrel jack. Those are
Okay.
just hooked in parallel. This is the
Okay.
power into the system. So one of the things running a Raspberry Pi is, what are you going to power it with?
Hmm.
And you rather than running off of the USB wall wart that plugs in here, I built a power supply onto the board. So right above the power pole, that's the 5-volt power supply. So it
Hmm.
creates a nice,
Right here.
5-volt rail to run the Raspberry Pi.
Hmm.
Um, then along the very top edge on the right-hand side, you'll see three RJ45 connectors.
Hmm.
Those are not Ethernet. And I need to
Oh,
make a
okay.
sticker to put on that says this is not Ethernet.
Not Ethernet. Okay.
Yeah.
All right.
So I'm going to use a term here. I want to define this term because I'll be using this over and over again. So the method that I use to interconnect all of the modules is a network kind of connection, network in quotes, that I call the device control network. The device control network can be either done wired or wirelessly. In this case, it's a wired version. And so what I'm putting on those RJ45 connectors is data and power. So if we
Okay.
were to power, let's say, just the Raspberry Pi module and then what you have to the right of it, which is the 4-port HF coax relay, the
Hmm.
only connection between the two is a little piece of Cat5 cable or Cat6 cable. So,
Okay.
so in the bag there somewhere, there's a short piece of Cat5 cable that we'll use to
Okay.
hook into that coax switch. Also, rotate the coax switch 180 degrees so the connectors are on the bottom.
This one.
Yeah, flip it around. There you go.
Okay.
Okay, so those four little black RJ45s, that's the hub for connecting to the modules. So you can plug a little piece of Cat5 cable between any one of those three modular connectors and the
These.
one. There you go.
Okay.
Yeah, just
Hmm.
between those two, and that will provide data and power to that coax relay. So that's
Okay.
the
Okay.
only connection you need to make. So
Okay.
it's really easy.
Oh, it's probably that. I was looking for that piece of Cat 5. Is
It's
probably
in
in this
there.
installation kit, right? Yeah.
Yeah.
Okay. Good. Okay.
So while you're doing that, so
Mhm.
the other things that are on that Raspberry Pi host adapter, there's a green connector up at the top. That's an auxiliary connector that has power and data also on it in parallel with the RJ45s. And there's times when you might want to use twisted pair for data or have twisted pair to power it instead of using a connector. So you have that option.
Okay.
Um, Also, you'll notice that right below the green connector, there's two
These
headers that
two.
are unpopulated.
Mm-hmm.
Can you take a wild guess what that's for?
No, I don't. I don't know.
That that's
Oh,
for a
an LCD screen. Or
no.
no, is that a
Yes,
Pi
it is.
Star?
No,
Wow.
it's a Heltec V3 Meshtastic radio.
It's Meshtastic.
Yeah.
Oh, wow. Okay. All right. Yeah. Okay.
So you can take a Heltec V3 module
Okay.
and plug it into those headers, and then you see the little SMA connector above it.
Yes, right there. Uh-huh.
That's for the Meshtastic antenna. So let me take a little time out and explain this.
Yeah, that's yeah, how's that going to okay.
Yeah.
And
So
now I'm curious. Okay.
you don't need Meshtastic at all for the
Okay.
system to work.
Okay.
Period. And it's not shipped with it by default because you don't need it.
Right.
So the architecture of the system is such that you have the main controller, which is your Raspberry Pi,
Mhm.
and then you have one or more modules which will measure a voltage, switch an antenna, do whatever it does. And I mentioned there's two ways to connect between the Raspberry Pi and those modules. You could do it
Mm-hmm.
wired, and the wired method is using Cat5 cable that
Mm-hmm.
brings over the data and the power. And normally, if you have a controller all together, you would just hook up Cat5 cables between the different modules and it just works.
Mm-hmm.
Now, there's scenarios where you want this device to be farther away than is convenient. And like maybe you have a tower that's a couple hundred feet away from your station, and maybe you want to do your coax switching or your watt meter or something at the tower, not in the station. So how would you do that? So there's two ways to do it. You could run a very long piece of Cat5 cable, which is fine
Mm-hmm.
because this you can run this data up to a couple thousand feet, no problem.
Mm-hmm.
So
Mm-hmm.
you could just run a big old long piece of Cat5 cable to the other side, and it would provide power and data to the other end. Or what you could do is replace that Cat5 cable with a wireless radio,
Mm-hmm.
a data link.
Mm-hmm.
And there's two kinds of radios that we support. One of them is a 900 megahertz data radio module that looks like this,
Mm-hmm.
and you simply put in a pair of wires into the block there and power, and this will transmit the data to another one just like this at the other end. So you now have a 900 megahertz point-to-point link. Or you could plug in the Meshtastic radio and do the same thing over Meshtastic. So you can have um, at the other end. I didn't send you one of these. This is a future thing. This
Okay.
is this is the Meshtastic module all by itself.
Mm.
So I could have this Meshtastic radio with Cat5 connection to a control module.
Okay.
And so I can send the command there, the system can send the commands back and forth over Meshtastic. Now,
Mm.
having said that, let me make a couple important points. Point number one is I don't recommend deploying this on long fast
Oh yeah, for sure.
because you're going to be
Mm.
like, "Hey Bob,
Yeah.
you want to have lunch?" And then here's, every 30 seconds is some data from some machine somewhere. So
Yeah.
that would drive
Okay.
people crazy. So if you're going to use Meshtastic, you need to create your own separate channel, and that also
Mm-hmm.
means you can turn on encryption if you want.
Yeah.
Um, the beauty of the Meshtastic radio is that I can run the Meshtastic app on my phone and I
Mm-hmm.
can actually watch the traffic and I can even send commands, if I know the command format from
Mm-hmm.
my phone.
Hmm.
Now, so that's what the Meshtastic thing could be used for, but
Okay.
it's not required. In fact, there's a downside to Meshtastic. The downside to it is latency. So
Yeah.
these 900 megahertz data radios are much lower latency than Meshtastic.
Okay.
So I only recommend using the Meshtastic stuff in if it's really necessary. Like I have a site up on a hill, I have no internet to the site. I
Mm-hmm.
can send a Meshtastic message to the repeater site, and I only ever need to like turn off the power, so it's not like a lot of traffic. Then the Meshtastic thing is fine. But for normal like high activity networks, I don't recommend it. I would use the regular data radios or the cable is much more reliable.
Okay.
Anyway,
Yeah, that makes
so I
sense.
just want to get that
Okay.
Meshtastic thing in there so
That's pretty
as
cool.
as
I
as
mean,
an
that's
option.
yeah. I wasn't expecting to see that at all.
Yeah.
So okay, good, good.
Okay,
Okay.
so that's it for the Raspberry Pi module. By the way, another maybe one last thing. Most of the people who are going to get this system, I think they're just going to want to buy it, take it out of the box, plug it in, and use it.
Mm-hmm.
So I can supply the Raspberry Pi board, I mean the host adapter and the Pi itself and the imaged SD card. So you literally just plug in power um,
Okay.
and data, and you're done. If you want to build your own, and of course it's cheaper this way, you can just get the board, supply your own Raspberry Pi, create your own SD card image, and go
Mm-hmm.
from there. But
Okay.
up to you, right? Whatever
Yeah.
people want to do.
Yeah. Okay. Good to know. Okay. Excellent. All right. So we're back over here, and these are those Ethernet cables.
Okay, so take one of those cables
Mm-hmm.
and plug it into one of the three connectors on the Pi.
Doesn't
There you
matter
go.
which one.
Doesn't matter. They're all
Okay.
bust together.
Okay. All right.
And then plug the other one into the coax relay.
Okay.
Okay. Now we just need to apply power to the Raspberry Pi. And
Okay.
that's a power pole or a barrel connector, so 12 volts into the Raspberry Pi connector.
So we want to power it from here, not from over here.
Correct. You
Okay.
never touch the Raspberry
You
Pi.
never have to touch it again. Okay.
Uh-uh.
All right.
And it'll run off of a, you know, a 1 or 2 amp wall wart or your base station power supply. So
Okay.
one of the reasons for putting the power supply on here is every ham shack has 12 volts. Um, and
Yes.
and if you're going to use like the Raspberry Pi wall wart, um, you have to have separate power for the rest of the modules. And it's like there's no point. So you might as well just have one 12-volt power input. It's actually a wide range
Yeah.
input. You can run it on anything from about 10 or 11 volts up to about 18 or 20 volts. So
That's good. Okay.
you know,
Good.
like,
Good. Good. Good.
so actually, while you're doing that, a little
Hmm.
sidebar, for remote station, one of the things you want to do is be able to run this thing off a battery if available. So in my station, what I do is I take a BioNO battery and I
Yeah.
plug the BioNO charger into the wall, and I plug the 2 millimeter jack into the battery, and
Hmm.
then I have a
Hmm.
little jumper that goes from the BioNO
Hmm.
battery's power pole to the power pole on the Raspberry Pi. So now the whole station controller is going to be
Hmm.
running off of the battery, and it's constantly being charged.
Constantly being charged. That's a good
And
idea.
if I lose power at the station controller is
Hmm.
still up.
Okay. Let me run inside and get one of my BioNOs because my overhead. I've got it sitting over here. This is my overhead camera, and I've got another camera that looks at my power supply and my incoming and my 12-volt connection. But it's over here to the side, so I don't have a power supply right here.
Okay,
So let me go grab that. So let's take like a 5-minute break, and we'll start again here in a second.
sounds good.
So there's no lights or anything. There's no indicators on here to see that this is powered on yet.
Oh yeah, there is, but it's not. Yeah,
It's
you
not
don't have 12 volts on there.
not seeing that. Is it the same wallboard that's
It's just 12 volt wall wart. It's a
Yeah.
2.1 millimeter barrel.
Is it the
You
same
could,
barrel that's on a BioNO?
yeah,
Okay. Okay,
uh,
so are we plugging into the Pi or are we plugging in elsewhere?
into the Pi.
Into the Pi. Okay.
Now,
There we go.
so on the display on
Hmm.
the coax switch, 1 minute after power is applied on the display, it's going to give you an IP address. So watch for
Okay.
that. Ideally, you'd have the network connection plugged in, then powered up, but
Yeah.
it'll
Okay.
probably be fine. So
Okay. Okay.
it takes a minute for everything to boot up, and at the very end of that boot process, it'll report what the IP address is.
Gotcha. Okay. Right now it says selected port 1. That's all it says.
Yeah, so by
So,
default, coax port 1 selected. So while that's booting, let me
mhm.
explain a few things on the coax switch there. So first of all, this is
Okay.
a HF coax switch, meaning it's good from 0 to 60 megahertz, so HF plus 6 meters. It turns out actually it's not awful at 2. So if you
Really?
could use it
Huh.
on 2 meters, it's not ideal. It was not designed for 2 meters, but it has maybe half a dB of insertion loss, which is nothing you would design for, but it's not horrible. But it's really intended for HF, where it's got like almost zero insertion, like 0.05 dB insertion loss.
Okay.
Um, the configuration on the BNC connectors there, it's
These.
from left to right. It's port 1, port 2, common, port 3, port 4. So if
Okay.
you had one radio and 4 antennas, you'd plug your radio into the middle one,
In the
and then
common. Hmm.
the antennas or dummy load would connect to the other ones. If you have 4 radios and one antenna, then the one antenna goes to the center port.
Hmm.
All of the relays are latching, which means that whatever position you put it in, if you
Hmm.
pulled power from that board, it would stay connected.
Mm.
And that's important if you're preparing for, emergency situations where you're going to lose power. The last thing you want is to turn on your radios and like the, the antenna's disconnected.
Yeah.
So that stays connected.
Okay. Okay.
The display on the module will show you the current state of that board. So it'll tell you which antenna is connected. There's a way that
Okay.
you can actually change the labels. So if, let's say, port 1 is your vertical and port 2 is your beam or whatever, there's a
Hmm.
way you can put that specific text on the display.
Gotcha.
Uh,
Good.
and you and
That's
you
good
don't
to
need the
know.
display. I think 9 times out of 10, people are going to just put this in a closet and close the door, and they don't even need the
Yeah.
display.
Yeah.
And this displays, literally, the display just unplugs from the
Yeah. You can
module,
just pull it
and
right
you
out of
don't
there,
even
right?
need to use the display. But
Mm-hmm.
for
Mm-hmm.
this purpose, it's good to see it.
Yeah.
Um, so that's the basic connections. There's some
Okay.
auxiliary stuff up at the top. The green terminal block
Mm-hmm.
connectors provide additional. The one on the right is additional network and power that parallels the RJ45. There's a 2.1 millimeter barrel connector next to the RJ45. Um, those are all hooked up in parallel. So we run the power over the Cat5 cable. You could take 12 volts, plug it into the barrel connector on the coax relay, and that'll just feed power over to the Raspberry Pi. So any of those connectors are all bused together.
Okay.
The last thing is on the upper left green terminal block. There's 4 pins on there, and there's actually 8, but 4 of those pins, if you momentarily connect them to ground, like through a push button, it will actuate the relay. So in addition to controlling the relay over the network, you can also have a set of switches to manually control the relay if you like.
Okay.
Also, you'll notice there's a USB-C connector on the upper left corner.
Right here. Yep.
Yeah. And so in normal operation, you never touch it. But if you, on all of the modules, they all have USB-C connectors that are connected to the CPU on the board. And the purpose for that is mainly to configure that module if you need to do anything custom. So the way the system's designed, normally you'd never ever need to configure anything. But there's some corner cases where you might want to adjust something, and then that's a way you can go into it with a dumb terminal and just type in commands and configure it. Also, when the device boots up, if you plug in a dumb terminal, you'll see all the different steps the thing goes through when it's booting, so you can see what's going on. It's kind of interesting to see once, but you don't have to do that.
Yeah. Okay. Okay. All right. Well, it came up and it said IP address a minute ago, but it was blank.
Okay, that means that the thing didn't catch the
catch
IP address. So let's pretend we're doing it from scratch. Now look over on the Raspberry Pi board. You'll see next to the barrel connector, there's a tiny switch that says shutdown.
Yes. Right
Press
there.
that button.
Press and hold, or
press
just
and hold that button for a second. Just hold it for a second. Let go. Okay, so now your Pi is going to shut down. So this is a better than yanking the power. So if you yank the power on an SD card Raspberry Pi, theoretically you can corrupt the SD card. So whenever you shut it down, it's better if you actually do a proper shutdown. Okay, so by now it should be shut down. So disconnect the 12 volts and plug it back in. So a couple other things. We'll go through the other modules in a little bit here, but currently there's 3 different kinds of control modules. This is the 4-port coax relay, obviously. There's a module that we call the general purpose I/O or GPIO module, and that's a pretty universal module. It gives 18 different channels of monitoring or control. So it's got built into it 4 DC voltmeters that could measure 0 to 50 volts. It's got 4 small signal SPST relays, so you can have dry contact closures built in. It's got 4 open collector outputs that could be used to control a large 12-volt relay, or like on a flex radio, for example, there's the soft power on-off remote jack on the back. You can take one of those open collector outputs, hook it to the RCA jack on the flex, and remotely turn the flex on and off through that jack. There's 4 opto-isolated digital inputs, so you can have a switch closure of some kind, like a door, alarm, or any other, switch to ground kind of input. And then there's 2 temperature probes. And the temperature probes, they're included in the package. There's like a 3 to 6 meter or 3 to 6 foot cable with little silver metal cylinder at the end. It's got a digital temperature probe, and so you can put those in the room, tape it to the PA or whatever you want to measure the temperature of. And otherwise, everything else is similar to the coax switch in that there's the network connection, the power connection, the auxiliary connections, same idea as the coax switch. So what would you use the GPIO board for? You'd use that to, let's say, turn your power supply on and off, to measure the battery voltage, etc. So it's general purpose kind of application.
Okay.
Did you catch the IP address on the?
Well, it was still blank. So, and I don't think it's not got a link light. Well, no, this. I don't remember if the Raspberry Pi is supposed to have a link light or not, but
I don't think so.
No, I didn't think it did. But
okay, well, you know what we could do is you could plug in your monitor and keyboard and all that stuff. We just go right into
Okay.
the Pi, or we can
Okay.
SSH into it. Either way.
Um. Well, you'd have to have an IP address to SSH into it, right?
No,
I
you can use the name of the computer. So if you have PuTTY or something handy on your
I
PC,
do.
we could do that.
Yeah.
Okay, let's give
Yeah.
that a try.
Okay. I could also open up my router if it did pull an IP address from the router and says host does not exist. I'm thinking that it's not. I'm thinking it's not connect.
I think it's not connected.
Yeah, I think it's not connected. So, but it's plugged into the same switch that I have both of my computers and my Flex radio and everything else on. So, I don't know if this piece of coax is bad or what the deal is with that.
Can you unplug your Flex and or something else and plug it in?
That's all behind the desk over there.
Ah.
That is a bad piece of coax. I have link lights on the Raspberry Pi now.
Aha.
So
How about that?
It does show up as links lights. Yeah.
Oh, it does.
Yeah.
Never noticed that. Okay.
Yeah, I can't say that I have either. So I've got a bad power pole and a bad coax and a bad Ethernet.
Is there anything else I can help you with debugging your shack?
Right, exactly. Yeah. I can't remember the last time I used that Ethernet port on anything. Okay, do we need to reboot for it to grab an IP, or should it do it by itself?
Well, let's do if you reboot, it will do that. But let's go in through SSH, and I'll show you how to do that.
Okay. All right. So let's pull that back up and just say.
Awesome.
Okay.
Okay. Perfect.
Log in as
Sierra, SIERRA.
I know there's
By
a
the way,
meaning behind that, but I don't know what that is.
Yeah, you're not old enough.
Oh, okay.
So if you go back to the 70s era of radios, when they had solid state receivers and tube finals, a very popular final tube in the Kenwood radios was a 6146.
Ah, okay.
So
Okay.
so there's a pair of 6146s there. That's your trivia for the day. All right.
Nice.
So
Okay.
now we're logged into the Pi. So what you see there on the prompt, since the name of the this is a little minutia, but since the name of the Pi is station controller, the prompt would be like half the screen, so it's abbreviated to just the $sign. And the name of the directory that you're in, which is tilde here, that means your login directory. Now, to make things really easy, type the word menu, hit return. Okay, so there's your little utility screen. The very first thing says get RPI IP address. So type 1 and hit return.
Oops.
Okay, there's your IP address.
Yeah, 1.51. Okay, good.
That's all you need to know.
Okay.
At this point, you never have to do this ever again.
Okay.
The other things on the little utility menu here are just housekeeping things. If you want to go hack around in your Raspberry Pi to customize it, then this, for people who are not very familiar with Linux, this menu helps you just find convenient configuration files and lets you reboot the machine and stuff like that. So we're done with this. This is all you need to do. So we can just exit out of here, and then pull up a browser.
Ah, there it is. Okay, take the automatically added S out of your HTTPS prompt. Okay, here we go.
And by the way, if you want to run this with HTTPS, then that's the user's problem to sort out how you want to run it securely. But
gotcha. Okay.
Okay. Now what you're looking at here, this is the dashboard, as supplied on the SD card image that is shipped with the product, and this has the control panel for 3 modules: for the GPIO module, for the coax switch module, and for the RF wattmeter module. Which the wattmeter module, you don't happen to have that board, because when I shipped you your kit, I didn't have those modules yet. I have them now, so we could do that another time. Now, the beauty of Node-RED is you could just take this as I ship it and just use it and never customize it, and it'll be fine. Or you can go in and customize it. So like if you said, well, I want 3 coax relays, well, you can go into the Node-RED editor and you can just copy my coax relay code and change the address, and it'll just work. So it's really easy to enhance and modify this to meet your own custom needs, or you can just use it out of the box the way I ship it. So what you see on the upper left-hand corner, that stack of green and red boxes, those are the 8 relays on the GPIO module. The big box in the lower left, those are the 4 ports on the antenna switch. So you'll notice that the antenna switch LEDs are lit up green, red, red, red. That's because we're communicating with the coax switch. The GPIO module is not plugged in, so those LEDs are grayed out, so because there's no data. So I pre-loaded labels in those four coax positions: vertical, beam, something else, and some dummy load or something. You can change those labels. That's really simple
Mm-hmm.
to do. But
Mm-hmm.
let's go ahead and select a different port. So click your mouse on one of those green bars.
Hear it clicking.
You
Okay.
hear a click, and you'll notice
Mm-hmm.
also on the board the LED changes, so you can tell which one is selected.
Yes.
So
Yes.
when you click this is important to kind of know for the reliability of the system. When you click a button like that to select the antenna,
Mm-hmm.
the dashboard sends the command over the network, the wired network, to the coax relay and says, I want antenna number 2.
Mm.
What the board does is it, first of all, it disconnects whatever it was hooked up to before. It waits a short period of time, like 300 milliseconds.
Mm-hmm.
Then it connects in whichever port you selected. So you're never gonna have the chance of shorting anything out. So there's a time gap between disconnect and connect.
That's a good
Um,
idea.
and like I said, they're latching relays. So if you pulled all the power right now, that circuit will still be in place. So
Mm-hmm.
it'll still
Mm-hmm.
be operational. Um, the other thing that happens is after the board makes that relay switch, the board then the control module sends a message back to the dashboard to say, here's my current state. And my current state is port 1, 3, and 4 are off, and port 2 is on. So
Mm-hmm.
when you see the LEDs change color,
Mm-hmm.
that's not because you pressed the button. It's because the remote device sent a message back saying, here's my current state. So
Mm-hmm.
that way you know something happened. So if you press, let's say, vertical antenna and it never changes to green, then
Mm-hmm.
something happened and the message never made it. Maybe there's a collision on the network or something got unplugged or who knows.
Okay.
So just because you press the button doesn't mean it happens.
Mm-hmm.
You only know it happens when the indicator says it. So click vertical antenna, the top one again. So it took about a second or two for the LED to update.
Right.
The relay actually switched immediately.
Yeah, you could hear the relay click immediately, and then it clicked again, and then that's when the LED immediately after the second click is when the LED changed.
Right. So again, what happens is press the button, the
Mm-hmm.
module gets the message, disconnects the relay, first click,
Mm-hmm.
very slight pause, connects the new relay, second click,
Mm-hmm.
sends the message back to the dashboard updates the LED. All that takes 1 second or so for that to
Hmm.
happen.
Okay. Cool.
And that's
Very
it. I
good.
mean, that's
Yeah.
all it takes to, the biggest pain is like, my network cable's bad. So, I mean, if
Yeah.
if you have
Yeah.
a good if you have a good network connection power supply, this whole thing would
Yeah.
take 5 minutes, right? So
Right.
that's
Yeah.
that's that.
Okay.
So
So
you want
these
to
so there's four options for voltmeter and four options for temperature sensor. Are those something I have here, or is that
yes.
something to be added later? Oh,
No,
okay.
you got it there. Let's go ahead and hook that up. So let's go back
Okay.
to the bench and we'll hook
Okay.
up the GPIO module.
Okay. Yeah. This is just one of these Ethernet cables?
Yeah.
Okay.
Plug it into one of the black connectors on the Pi board,
Mm-hmm.
and then plug it into the corresponding connector.
Okay.
And you don't have to reboot anything. It'll all
Right.
self-heal when it
Yeah.
comes up. So the board's up and running now.
Okay.
So if we go back to our dashboard,
Yep. Yeah, it's already lit up. They're all
um,
red, but it's all lit up.
yeah, so it's already got an update. Um, so go ahead and click one of the green relay buttons on, like one of the first four ones. You'll hear it click, like relay 1.
Yep. Slight click.
There you go.
Okay.
So what you see here is there's the relay 1, 2, 3, and 4 are the little white LEDs, the little white relays on the board. Those are single pole, single throw,
Mm-hmm.
2 amp maximum contacts, and you can put
Okay.
whatever you want through there that's 2 amps or less. Then the next four relays are open collector outputs, and what that means is that when those are active, that output will be pulled to ground. So there's a 500 milliamp capable transistor that's pulling that signal to ground. So it's a solid state kind of a switch. And what would
Mm-hmm.
you use that for? If you said, well, I need to switch like a 30 amp power relay. Okay, you go get a power relay with a 12-volt coil, and you would
Mm-hmm.
hook up 12 volts to one side, which I supply out of the board. and you hook up the open collector output to the other side of the relay, and and there you go. Um,
Okay.
there's some little relays that are in your installation kit. They're little DIN rail mountable, skinny little relays that I put in there that you could hook up to that as an example.
Okay.
Okay, then to the right of that, it says digital input. There's four opto-isolated digital inputs. What this
Mm-hmm.
means is if any of those four inputs are pulled to ground, then that LED will turn on. So what would you use that for? Well, like if you have a remote site, you might want to put a door alarm on the building or on the cabinet,
Mm-hmm.
or, I mean, it's a universal thing. It's a switch closure. Um, then to the right of that, it says voltmeter. And like you said, there's four voltmeters stacked up there. So the
Yeah.
voltmeters on this system can read from 0 to 50 volts
Okay.
DC, and they're all system ground referenced, which means they all, whatever you're measuring, that 12 volts, it has to be the same ground potential as the controller.
Okay.
So typically, I mean, and normally it would be. And what would you use the voltmeters for? Like in my station, I have it hooked up. The first thing I hook it up to is the output of my power supply,
Yeah.
because I want to know, if the power supply is working or
Mm-hmm.
sagging or whatever. And if I'm on battery backup, I want to measure the battery voltage, which could be the
Okay.
same point in the system. So let's say, for
Mm-hmm.
example, if
Mm-hmm.
your station has a big 100 amp hour lithium iron phosphate battery, you want to hook up one of your voltmeter inputs to that battery, and you might have a charger or power supply keeping that battery topped off. And when you lose AC power, the battery is still running, but you want to see what the battery voltage is to make sure it's still
Right.
looking healthy.
Right.
Then to the right of that are temperature probes. There are three on the dashboard. There's two jacks for temperature probes, and the software supports a third one that's not on the board. So there's really two temperature probes, and again, those are little. There's like a 3 to 6 foot cable with a little capsule at the end, a little metal capsule.
Yeah.
You plug in the wire through a terminal block, and then it'll tell you what the temperature is. No calibration required.
Now these are all connected through these four
Yeah,
terminals
so
here on the bottom of the GPIO board.
Yeah, so
Okay.
hold up the GPIO board
Okay.
there. So you'll see, yeah, there's a row of connectors at the bottom.
Yeah.
So and if you look at there's little plugs that plug in there. So the actual place where you put the wire is a pluggable connector. So there's a little block, and it's a rising clamp thing. So you unscrew it, you stick in the wire and screw it down, and then you plug that thing into one of those connectors.
Into here.
Yeah.
Okay.
The
Okay.
nice thing about that is, let's say for some reason you want to remove the controller.
Mm-hmm.
You don't want to
Yeah.
unscrew 18 wires or more.
Right. Right.
So
Yeah.
you just unplug the terminal blocks and then swap out the board
Gotcha.
or whatever.
Gotcha.
And you'll
Okay.
see silk screen on the top of the board. It'll tell you that the left block is the analog voltmeter input.
Yes.
So each pair of pins is like voltmeter 1 and ground, voltmeter 2 ground, voltmeter 3 ground, voltmeter 4 ground. That's the 8 pins
Gotcha.
on that block. The next one over is the open collectors. So
Mm-hmm.
each pair of pins is like open collector output and a 12-volt power out.
Mm-hmm.
So you
Mm-hmm.
can power a relay.
Yeah. Right there.
The
Mm-hmm.
next block over are the four little white internal SPST relays. So that's 2 pins per relay.
Okay.
And then the fourth block to the right is the pull to ground digital inputs
The
through the opto
digital. Yeah.
isolators.
Right. Okay.
And then along the upper top, the two 3-pin connectors in the middle, those are the
Right
two
here.
temperature probes.
Oh. Okay. Okay. So specific probes for temperature. Okay. Good. Good.
And again,
What?
those are
What?
not thermocouples. They don't require calibration. It's a digital
Right.
temperature probe. You just plug it in, it just works.
Okay. Nice. What's this one here?
That's a system connector. All the boards have this, and it's just extra connections for network and power. So if
Okay.
for some reason you didn't want to use the RJ45, you had a twisted pair you want to plug in. So let me give you kind of, here's a like an advanced tip.
Okay.
So one of the things you could do, if you're for normal use, you don't have to do this, but if you're curious and want to see what's going on the network, inside your installation kit, there's a little USB dongle, that little blue dongle.
Okay.
And on the back end of the dongle is a little 2-pin screw terminal. And what that's for is it's there you go. So that's a USB COM port FTDI chip in there,
Mm.
and it
Okay.
goes from the USB connection, enumerates a COM port, converts it to RS-485, which is what my network connection is, and that's what
Mm-hmm.
those 2 pins are. So on that upper left-hand corner terminal block,
Right here.
there's two pairs
Mm-hmm.
of what's called the AB signals for the RS-485. So you can just take a piece of zip cord, like your, 20 gauge black and red zip cord,
Yeah.
and put it between the terminals on that little blue thing,
Mm-hmm.
and then two pins on that extra system bus, and
Mm-hmm.
then you could pull up putty, and you could watch the traffic on the network going back and forth between
Oh, nice.
the Raspberry Pi and the module. Now,
Okay.
for a normal, appliance plug and play black box kind
Mm-hmm.
of deployment, you'd never do that. I mean,
No.
there's no reason in the world you'd ever want to do that. But
Right.
if you're curious what's going on,
Mm-hmm.
and you want to see what's actually happening under the hood, it's kind of fun to watch the traffic bouncing back and forth. So what you'll see
Sure.
is the Raspberry Pi will pull each of the modules. So it'll
Okay.
say, hey, module number one, what's your status? Module one will measure all the inputs and send them all back to the dashboard. Then it'll go to
Mm-hmm.
module two, then it'll go to module three. And so it round robins through all the three modules if you have the
Mm-hmm.
third one there. Um, and then updates so the dashboard is updated about every 30 seconds
Mm-hmm.
automatically.
Mm-hmm.
Or if you command anything on a board, it will automatically update that module when you
Mm.
do the command.
Okay.
So that's the
That's
that's the
pretty cool.
basics. You've basically
Okay.
done the setup. Now the
Yeah.
only other work to do is to actually hook it up to something.
Yeah. 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 So these are all BNC connectors here. So I would need like a well, currently I have the Alpha Delta 4 position switch on for my HF radios because I have I'm trying to remember my latest configuration. I think I have one antenna to the common, and then I have my my Flex and my IC 7700 that go and then I have an extra cable that comes up here on the workbench for doing video stuff and whatnot, plugging in extra radios and whatnot, and they all go to the one antenna right now. So I would probably want to plug that antenna into this middle port,
Mhm.
and but those are all PL259, so I have to get some adapters, which is
So
big,
or look in your bag. You might
which
find some coax cables in there.
oh, I did see those, yes.
Yeah,
Okay.
break those
Yeah.
out.
Oh yeah. Okay. So yeah, that's
So
BNC on that end and PL259 on that end. Okay.
yeah,
Good.
so those are going to be optional. They don't come with the board, but
Okay.
and the reason
Okay.
is that people may just be using BNCs. I mean, most of us for our HF radios we use PL259, SO239.
Right.
So they'll be available as options to go with the kit. Now, you might say, well, why in the world do you use BNC connectors? And there's a good reason for that.
Mm-hmm.
If you're building uh, a device like this where it's on a printed circuit board, there's
Mm-hmm.
no such thing as a SO239 or N connector for a PC board. They don't exist. So
Right.
the only connector that you can really use is a BNC or like an SMA. I don't want to do that. So
Yeah.
a BNC is a perfectly fine connector, and it keeps it kind of compact to boot.
So
So
it's also a lot smaller. I thought that's what you're going to say. Is that just 5 in a row SO239s would take up a whole lot more room than this.
exactly, yeah,
So okay.
exactly.
Good.
Now I'm thinking I may build a bigger switch box in the future with more connections. It's a box that has PL2 or SO239s, but that's like someday maybe.
Yeah. Okay. All right. Good. Local IP address to connect to this system station controller from within the LAN.
So that's a good question. So right now that problem is up to the user to figure out. So
Okay.
the simple answer I'm not wild about. The simple answer is you open a port on your router, and
Mm-hmm.
you know the WAN address of your router. So when you're out and about, you point to the WAN address and the port, and then you'll see the web page. Now the problem with
Mm-hmm.
that, of course, is now that's a vulnerability.
Right. Mm-hmm.
But like when you run your Flex, you have to open up, ports to talk to your
Yes.
Flex.
Correct.
Although SmartLink does kind of help you with that. So
Mm-hmm.
one of the things that we're working on is looking at doing something similar to SmartLink, where
Mm-hmm.
you would have a server you would log into, which would then essentially proxy to your device at home, which would give you a layer of security. So that's probably a better approach.
Mm-hmm.
A lot of people will do a VPN, or they'll do some, people. There's a lot of hams who are really networking experts, and they have 16 different ways they'll do it. But for
Yeah.
for the casual non-network expert, then besides opening up ports, we're looking at at having a, proxy service to make that available. But that's not
Okay.
going to be a free thing. That's like a subscription thing. But
Yeah.
that's not our business model is not to have a subscription model where you have to use a service. This is all self-hosted, and self-run, and that would just be like an option if you really wanted to do that. And that's not
Okay.
available yet anyway. Probably later this year.
Right. Right. Yeah. Okay. We could always use like some sort of remote desktop or VNC
For sure.
to get into your network, which is what I use a lot of
Absolutely.
times anyway.
Yeah, actually,
Because
remote desktop is a really good idea because that way you
yeah.
don't even have to. Yeah, you just point to that. And now,
Right.
by the way, the other things you see on this dashboard here on the right-hand side is the RF watt meter. You don't have that
Hmm.
module there, um, but I did get those modules. There, I've got them now. They're up and running. They're
Okay.
working fine. The way the RF module works, it looks very much like the coax, really, except it's got two ports on it to talk to two RF directional couplers. So that means you can essentially have two watt meters built into the system for one with each module. You can have more modules, but
Hmm.
per it's
Hmm.
two. So the way it works is I didn't want to make the actual directional coupler itself, and there's a fella who I've worked with before that makes them they're very good. He has a company called WaveNode,
Hmm.
um,
Hmm.
and WaveNode makes watt meters and they make their own directional couplers. And it's very easy to integrate their directional coupler into my system. So I just built it around their couplers.
Okay.
So their directional couplers are a little box. There's two connectors, SO239 or N, and they make different wattage and frequency range models. So there's three of them that are supported in the system currently. There's um, the HF1 meter coupler, which is 0 to 2000 watts, HF and 6. There's a low power HF one that's good for 0 to 60 watts. And
Hmm.
then there's a UHF VHF model that's good up to, I think, a couple of hundred watts, up to 300 or up to 500 megahertz or something. So for like 2 meters, you'd use the UHF one. Um, you can plug any of those three directional couplers into either of the two ports, and then there's a way that you tell the watt meter what the personality is of that thing. So let's say I have my flex radio and my ICOM 9700. I
Hmm.
would take the HF coupler, plug it into port one, take my VHF coupler, plug it into port two, and then I would go through the USB port on the module with PuTTY, and there's a couple of commands that tells it what kind of module I'm using, and then everything is pre-calibrated and goes from there. So there's a couple ways that the watt meter thing works. One thing is that you can probe the status of the module, and the dashboard every 30 seconds probes every control module and says, what's your
Hmm.
status? So
Okay.
when you do that, if there's any power being measured from either of those ports, it will show up on these gauges. So you can see the upper right-hand corner is port one. So that's the
Hmm.
first coupler. 1 meter is forward power, the other meter is reflected power. And
Hmm.
then below that is watt meter two, the second port, same thing, forward and reflected power. So this is kind of the passive way to do it, where it's just constantly measuring it and giving you an update about what's going on. The other thing you can do is you can force a test. So the
Hmm.
buttons
Yeah.
below that says run RF a watt meter test on port one and on port two.
Hmm.
Now what that does is it keys the transmitter, measures the power, and returns the value. So this is really more useful for remote operating. So think about it this way. When you're operating remote, you're not going to want to watch the watt meter constantly. What you want to do is maybe when you start, I land in Hawaii, I pull out my tablet, I
Hmm.
want to connect to my Flex, and I want to see, how much power am I putting out? So you go to the dashboard, you hit
Hmm.
run watt meter test, and it'll tell you the forward and reflected power. And then you'll
Hmm.
say, okay, I'm good to go, and off I go. Now, the way that works is on the watt meter board, there's a couple of extra optional pins. And one of the pins on each port is a push to talk line. So when you press that first big green button,
Hmm.
it tells the watt meter, first of all, to key the radio. So it pulls the PTT line low, keys up the
Hmm.
transmitter, then measures the wattage,
Hmm.
and then unkeys the transmitter and returns that wattage back to the user. Now, currently, if you're in you have to put the radio into CW mode, and
Yeah.
then you have to do a key down with the PTT, then it'll work just fine. One of the
Hmm.
things that I want to do with this is to add like for example the Flex radio control API so that
Mm.
it'll tell the flex radio to do that automatically.
Mm-hmm.
I've had requests to add hamlib to the dashboard, so you can hook up, your ICOM 7300 and do the same thing.
Mm-hmm.
So those are
Mm-hmm.
enhancements that I'm going to make to this over time. But
Okay.
but right now that's the way it works. The other thing that's useful is if, let's say, you're using this on a repeater system,
Mm-hmm.
there's also a optional input pin that is a PTT input, and you might say, well, why would I want that?
Yeah.
So imagine this: you've got the watt meter on your 2 meter repeater,
Mm-hmm.
and one day you go, the repeater's off the air. What's going on? And you key up, you don't hear anything. You go to the dashboard, you hit run the power test, and it
Mm-hmm.
comes back with 0 watts.
Mm.
Okay, I 0 watts is a problem,
Yeah.
but I want to know, did the transmitter think it was being keyed up at the time? Because if you
Okay.
measure 0 watts, that's either really bad or irrelevant because the transmitter's not keyed up.
Mm-hmm.
So you can both monitor the state of the PTT line to the transmitter, and you can also force it to PTT through the watt meter
Okay.
module.
Nice. Okay. Okay. These watt meters you're talking about from WaveNote, is that a hardware or is that a software watt meter?
Oh no, it's a piece of hardware. So when you
Okay.
buy a watt meter from WaveNode, they have a
Mm-hmm.
control head and they have a directional coupler.
Okay.
So to use with
Okay.
our system, you don't need the watt meter control head at all.
Right.
All you
Right.
need is the directional coupler. And by the way, like the HF directional coupler is like
Mm-hmm.
$65.
Mm.
So
Oh,
I mean,
okay.
it is
That's
really,
yeah, that's
really
not bad.
reasonably priced.
Yeah. Yeah. Okay.
That will force the
Yeah.
IP address out to
Puts
the module.
That's what it did. Yep. That's exactly what it did. Okay. Yeah, this module right here. So
And then
cool.
on the dashboard, you'll notice that in the upper left-hand corner of the dashboard, there's the usual little hamburger.
Yep. Mm-hmm.
If you click on that, you'll see there's a second page that's Pi Monitor. So this is a generic Pi computer status page.
Okay. That every time I do a video about a Raspberry Pi something something, people are always commenting, "Wow, that's CPU temperature is high." It's like, well, yeah, it's not. I've got the heater going because it's 40 degrees outside right now. So, and there's no fan on this Pi.
Yeah.
Is there? I guess since the Pi's upside down, you can't really add a fan to the CPU on this thing.
Not to the
So,
not to the top side. So
yeah.
it's not just air cooled.
Right.
Usually they don't tend to run quite this high, but it seems to be fine normally.
It's a little high, but again, it's warm in here right now, so I can adjust that accordingly. But yeah, good. But that's good that you can monitor the actual Pi though. You can see how much disk space and whatnot.
So this is the beauty of Node-RED,
Mm-hmm.
that I built this dashboard and you can just go use it and it does what it's supposed to do and you never
Mm-hmm.
have to touch it. Or I think like a lot of us, the first time you use something, you don't want to start from scratch. You want to just start working. But
Right.
once you start to get the hang of whatever the thing is, then you
Mm-hmm.
start thinking, I could do this if only I had a way to get to it. And
Right.
so the nice thing about Node-RED is you can extend it as much as you want,
Mm-hmm.
and become as much of a Node-RED guru as you want to.
Mm-hmm. As you
And
want to.
there's literally thousands of people doing this because if you go
Mm-hmm.
to groups.io and go to the Node-RED ham radio forum, there's
Mm-hmm.
like 2,000 plus members of that forum alone.
Oh wow.
Um,
Okay.
so there's a whole lot of people out there that are doing these things, like Mike and like Kyle AA0Z,
Mm-hmm. Mm-hmm.
and a lot of other people that are very knowledgeable. And um, to add functionality, it's really pretty easy. You just
Mm-hmm.
go through the web browser, you point to a different IP address, you see all the flows, and you can modify them or copy them or add in something else.
Mm-hmm.
Um, and it just works. And so what we're going to distribute is this software in two forms. One is the SD card image, which has the operating system pre-configured with all the things that you have to do. And there's like
Mm-hmm.
a dozen or two things that have to be done to configure it properly, but that'll all be pre-configured on the SD card or on the image that you could download. And then there's the flow, which is the dashboard. That's also pre-installed, of course, but that will evolve over time as we add more things to the Node-RED environment. There may be new libraries to add or new flows with new features, and those will be separately downloadable, so you don't have to re-image the thing, although you could,
Mm-hmm. Mm-hmm.
uh, or just download the new flow and run that.
What kind of time frame are you looking at before this is available to the public?
So the first thing I wanted to do is well, step one is prove to myself that it works. So that
Yeah.
was really
Yeah.
2024 was mostly like, get it to work to the point that I'm happy to share it with somebody else. My second goal was to get betas out by the end of December.
Hmm.
And so currently 11, there's 11 beta sites, the last two of which I still have to ship. So there's 9 betas that are actually out in the field right now,
Okay.
two more to get shipped. And all the feedback I've gotten so far, there's nothing in any of the feedback that would lead me to change anything on the hardware, or even the
Mm-hmm.
firmware for that matter. Although I can think of more things I want to do, but for right now, I think it's pretty stable and solid.
Hmm.
Um, then most of what I've been doing in the last couple of weeks has been documentation,
Hmm.
because there's 101 questions
Hmm.
that people have,
Yeah.
and so I've
Yeah.
been trying to capture all those. One of the reasons for the beta is to find out what people like or what they don't like or what's working and
Hmm.
not working. And so far everything is working the way it's supposed to be working, and most of the feedback are things that I just haven't gotten to yet, which is good.
Hmm.
So anyway, that's sort of the background. My goal was always to have them available for sale at Hamvention. So
Okay.
I'll be at
Okay.
Hamvention this year. I'll have them with me for sale. But
Okay.
based on the way things are going right now, I will probably have them for sale before then. So
Okay.
most likely, I would say February, March, probably they'll be put up
And
for sale. I still have to figure out the final pricing
okay.
for all this,
Okay.
and how, what all the variations are. Like, for example, my first thought a long time ago was, I'll just put instructions on how to configure a Raspberry Pi, and people will just have their own Raspberry Pi. They'll just get the Raspberry Pi motherboard and then do the
Hmm.
Pi themselves. Everybody in the beta group are experienced. They've done this sort of thing before. Their
Right.
Raspberry Pi Linux, not a problem. Everybody was like, "This is a pain in the neck." So
Really?
totally. And it turns out that the documentation was actually not too bad. It's like, do this, do this, do this, do this, and
Uh-huh.
in a half hour you're done building the image. But even
Oh
people that are
yeah.
very experienced are like, I'm too busy with life to do this. Can I just get it? And so
Yeah.
so
Yeah.
I decided that I'll just distribute the pre-created SD card image like you imaged.
Uh-huh.
And
Uh-huh.
in fact, I bought a pile of Raspberry Pi 3s because I know for sure there's people that are like, I don't want to screw the thing into the board. I just want to get it. So what I'm going
Yeah.
to do, Jason, is for those people who just want to spend the money and get it and literally go click click and it works, then I'll
Hmm.
have everything pre-configured, Raspberry Pi mounted to the board, SD card installed, everything is, done. Click it together, you're done. And for those people who are thinking, this is great, but I want to spend as little as I can, and I've got
Yeah.
stuff, I got a Raspberry Pi, I've got a, you know, whatever, I got cables,
Hmm.
then
Hmm.
I'll probably have some of this stuff as kind of not kit form, but like pieces. So,
Sure.
you can get the
Yeah.
Raspberry Pi board without the
Hmm.
Raspberry Pi, or you can get it with it. But if you get it with
Hmm.
it, I got to pay somebody to create the image and install it and test it. So that's not
Yeah.
free. So it costs me
Yeah.
money to do that. So I have to like jack up the price. So if you want to do
Hmm.
your own, that's great. If you want me to do it for you, that's fine too. It just
Hmm.
costs a little bit more. So right now I'm shooting for every one of the modules in the like fully baked, mounting hardware, everything ready to go out the door, probably somewhere in the $200 price range per module.
Okay.
So what that means is if you wanted the most basic configuration, you'd get the Pi module and let's say the GPIO or the coax switch module. So it's like $400
Hmm.
to start and $200 to increment up every additional module. Or if you want to, do it DIY a bunch yourself and BYO Raspberry Pi and all that sort of thing,
Hmm.
then maybe starting around 300. So
Okay.
that's kind of the price range that I'm looking at.
Okay. That's fair. For all it does, it's pretty good, I think. So,
Yeah, I mean,
okay.
the thing, the challenge here in doing a ham radio business is like if you built this thing and sold it to the commercial world,
Hmm.
you'd charge more than twice the price for something
Oh
like
yeah.
this.
Yeah.
But
Yeah.
but we're all hams and we're all cheap
Yeah.
and
Right.
we want the good thing, but we don't want to pay any money for it. So, I'm sort of
Yeah.
riding that fine line between uh, you know, this being financially successful and
Hmm.
just a pain in the neck.
Sure. Yeah. Totally. Cool. Has anyone ever mentioned adding a camera to it so that you can remotely monitor your Hamshack?
No, that's never come up. You
There you
certainly
go.
could do that. Um, I mean,
I mean, like,
I know a lot of remote guys who do that. I mean, that's
yeah,
not an uncommon
yeah,
thing.
I know a couple of remote guys that have just like, I mean, they have temperature sensors. Like, I know one guy who has a house in the mountains in Colorado, 1,100 feet above sea level. I want to no, 11,000 feet above sea level, I think. And he has a tower out there, and he's got the tower set up to become a 160-meter vertical antenna, but he's got I think a step IR on top of it. But he's got the total remote control system set up, and I think he just pieced it all together himself. He runs Flex mostly, and he was talking. He was like, "Man, I sure would like to see what's going on." But the most important thing, that being in the mountains in Colorado, he wants a temperature sensor. He's like, "I don't want it to get too cold. If the heater stops working or whatever." So temperature sensor is really important. But it is nice. It would be nice to be able to see your Hamshack from
So there's two
from a
reasons you
remote
kind of want to
location.
use a camera. What that I've seen, this is an industrial kind of IoT applications. I've seen
Mm-hmm.
this done a lot where people put cameras up to look at their equipment. They do it for two reasons. One is they want to see the equipment to see if it's like physically intact, right? So there's that
Right.
mechanical side of it. I get
Yep.
that, and that's a thing. But a lot of times I've seen people have like a panel of meters and a camera looking at the meters.
Mm-hmm.
I'm replacing that with
True.
stuff.
Yes. Yeah.
So, and it's much more useful than having a camera.
Mm-hmm. Yeah.
So, and the reason is, first of all, it takes less data, right? You can
Mm-hmm.
actually, you could, by the way, let's say you have a repeater site or a remote radio site where you have no internet, which is kind of
Mm-hmm.
hard to do with like a Flex, but let's say it's a repeater.
Mm-hmm.
You got no internet. You could put like a 20-year-old packet TNC on a 2 meter repeater at the repeater site and run all of the data that goes from the Raspberry Pi to the remote
Mm-hmm.
site over a low bandwidth data link. It'll work fine.
Yeah. Yeah.
So you can actually monitor and control stuff remotely using a LoRa radio, using
Mm-hmm.
a
Mm-hmm.
TNC or whatever. Um, so there is that aspect of it
Mm-hmm.
as well.
Mm. Good deal. Okay. That's just something I thought of when you were talking about all the stuff that could be added to it. So,
By the way, one thing we didn't really talk about is automation.
okay.
So so far what we've really looked at is kind of the core capability, which is I want to have a dashboard that shows me what's going on,
Mm-hmm.
and that's great. And if you want to go control something, that's appropriate, or if you want to just take a glance at what's going on, that's fine. Um, in the case, let's say your friend's case up in the mountains where
Mm-hmm.
he wants to know when it's too cold. Well, you can keep looking at the dashboard every 3 minutes, or you could add some automation in Node-RED. So this is really where Node-RED is super powerful. So
Mm-hmm.
you could enhance the flow that I provide by stitching a few things together. So for instance, it's very easy to do something like uh, I, I scrape the data from the modules every 30 seconds. So you'll get the temperature every 30 seconds. Now, all I'm doing is displaying that on the gauge. You could add a little couple of objects to that flow, and you can say, okay, if the temperature is below X, then do something. So if the
Mm-hmm.
temperature is below X, turn on the heater. Or if the temperature is below X, send me a text message. If the temperature is below X, then, I don't know,
Mm-hmm.
do
Yeah.
something.
Yeah.
So it's very easy to start to connect these things together to really
Mm-hmm.
automate stuff.
Mm-hmm.
So like an example, I have a user right now who has a repeater site and they have a power amplifier on the repeater,
Mm-hmm.
and it's like a 200 something watt Motorola, I don't know, Quantar or whatever thing. What they
Mm-hmm.
want to do is they want to be able to take the amplifier out of the circuit,
Mm.
and run low power if the amplifier fails. So what they're
Yeah.
doing is putting coax switches on either side of the amplifier and the watt meter. And if the reflected power ever gets above a certain amount, they'll take the power amplifier out of the circuit and just run straight through,
Mm-hmm.
and then send a text message to say, hey, the reflected power is too high. We've just taken the PA out of the circuit. Or you could imagine you could do the same thing. Let's say AC power fails, you're on battery
Mm-hmm.
backup. If you're on
Mm-hmm.
battery backup, turn down the power or disable the PA
Right.
or
Right.
whatever
Right.
steps you would take to switch to the
Right.
low power operational mode. And all that stuff could be done automatically in like, 5 minutes with Node-RED.
Yeah. That's a good idea. Yeah. I think this is a great project. It's I didn't quite understand what the purpose was when you first emailed me, and I'm like, because you had mentioned repeater controller. I'm like, okay, yeah, that's fine. I don't own a repeater site, but now that I see this capability here in the remote Hamshack, this is a really neat tool. I think there's a lot of room for expansion, a lot of room for adding new things to it to see what people want to do. So I think this is a great project, George. I appreciate your time today.
Sure. I got one little other side application. I could talk your ear off.
Yeah, sure.
So here's one other thing. Do you have a Stream Deck?
I don't. No.
Okay.
No.
You know what a Stream Deck is?
Yeah. I ran the software version on an Android tablet for a while. Now it worked fine, but yeah, I've never purchased the actual hardware.
So in my shack, I have one of the antenna switches in the shack, and I have a Stream Deck. So for those people who don't know, Stream Deck is a little box with buttons on it, and it's normally used to run programs like OBS or Adobe, whatever. But what I wanted to do is I wanted to do all my antenna switching either through the web page or through the push buttons. And so I wrote a little utility that runs on Windows. And so you press a button, and the utility translates that button press into the command that will switch the antenna relay. So on right in front of me in the shack, I have the Stream Deck, and each Stream Deck button has a picture of the antenna, or actually the radio. I have one in that case. I have one antenna and 4 radios. So I've got a little flex icon, a little Elecraft icon, a little icon, and then an auxiliary. And so I press the mechanical button. I don't look at the web page for this. I just press the mechanical button on the Stream Deck, and it sends the command to the network to switch the antenna relay. So there's all kinds of ways you could use this stuff. So
yeah, definitely. That's fun. I've heard of people interfacing Stream Decks directly with their Flex Radio before to change stuff.
Yeah.
So yeah, that's not a new thing, but yeah, that's great that it'll interface with that as well. So cool, man. Well, can't wait to see how it progresses and what new things people come up with. And are you going to? You said you're going to Hamvention. What about Hamcation? Any?
No plans to go there.
Okay.
But so Hamvention will be the first place where I'm going to show it off.
Okay. Sounds good. Well, thanks for your time today, George. I appreciate it. And we're going to follow this along as it goes. We'll get together again in a few months and see how you're doing with it.
Thanks a lot, Jason. Really appreciate it.
Yep. Thank you.
73.